Next question. If the net force on an object is equal to 10% of its weight, then what must be its acceleration? Well, what's weight? Weight is the force exerted by gravity on the object. So gravity exerts some force, and the acceleration of gravity on any object that falls freely, in other words, any object that's subject to a net force equal to its weight, is, well, our 1,000 centimeters per second squared, our 980 centimeters per second squared, if you want to be more precise, our 1,400 centimeters per second squared, if you want to believe my data. So what's going to be the acceleration if we have 10% of the weight? Well, if we have 10% of the weight, we have 10% of the force exerted by gravity, which is going to give us an acceleration that's 10% that of gravity. So the result is very straightforward. And of course, I used this to kid one of our students a little bit who wanted to know the mass of the object because he wanted to use his habitual use of Newton's second law and so forth. Okay, he already knows how to analyze uniformly accelerated motion in a fairly sophisticated way with equations. And the point I made there is you don't need it. And if you use equations, you're going to have to do quite a bit of work to figure out why you don't need it. If you just go away from the equations and focus on the basic fact that the net force on the object, well, the force exerted on the object by gravity, if that's the net force, it results in the acceleration of gravity. So if you have 10% of the weight, you're going to have 10% the acceleration of gravity. And a little more analysis. Weight is a force exerted by gravity on a mass. Acceleration is net force divided by mass, which tells you the thing that you really need to go beyond conjecture. You know, it seems like common sense. If you got 10% of the weight, you get 10% of the acceleration. But this confirms it. It confirms that the acceleration is directly proportional to the net force. So if you've got 10% of the net force, you have to get 10% of the acceleration, assuming your mass is the same both times, which is the implicit assumption here. So 10% of net force implies that you have then, that's at 10% of mass, and that really doesn't make a lot of sense. That is 10% of the acceleration, not 10% of the mass. I think I was thinking ahead to this problem. Okay. We should have the idea there. Now let's move on to number 4. You have 2 dominoes suspended, one on each side of a pulley, kind of like in the picture here. And so you have an acceleration, because in most cases, if you pick 2 dominoes in this lab at random, one is going to be more massive than the other. So typically when you hang them on a low friction pulley, the pulley will go one way or the other, indicating which mass is greater. So we have 2 dominoes. They have some difference in mass, and in this case they appear to accelerate at about 2% of the acceleration of gravity. And what we want to do is figure out what the difference is between the 2 masses. Well, the net force is 2% of the weight of the system. Okay, what's the weight of the system? It's the weight of 2 dominoes. And 2% of the weight of 2 dominoes is 4% of the weight of 1 domino. So our net force is 4% of the weight of a domino. Now, the net force, if we label this diagram a little bit, hopefully you can read this. We've got M2 here for the mass of this domino, M1 for the mass of this domino, F2 and F1 for the forces exerted on these dominoes by gravity. So we have F2 greater than F1, and the net force is F2 minus F1. Net force is the difference in the forces between the 2 dominoes, and the difference in the forces exerted by gravity on the 2 dominoes. In other words, the difference in the weights of the 2 dominoes. So we could also call this weight 2 minus weight 1. Now, according to Newton's second law, each weight is equal to the mass times the acceleration of gravity. So the difference here, we can factor out the acceleration of gravity. The difference here is going to be the difference of the two masses multiplied by the acceleration of gravity. And it's going to follow then that the difference of the two masses is 4% of the mass of one domino.